Hello and welcome. Today we are going to see the working of a 555 IC. How a 555 IC internal circuit is diagram will be and how it is working. This is a simple diagram of a internal circuit of 555 IC. It mainly consists of 3 resistors inside it, and 3 resistors are 5K. So its name comes as 555. In order to understand the working of it, we will check the working of a circuit diagram. With that we can understand this 555 IC internal circuit and its working. So if we apply 12 volt at the 555 IC VCC, the voltages at this point will be, as this is 3 resistors of same value are connected, the voltage at this point will be 1/3 and the voltage at this will be 2/3 and this will be full voltage, and this point is 12 volts. So the 2/3 of the voltage of 12 volts means 2/3 of 12 is 8 volts. At this there are 2 comparators are there and one SR flip-flop is there and a transistor is inside this IC. So if we divide the voltages, the 12 volt, 2/3 of the voltage will be available at this point. 2/3 of 12 volt means 8 voltage will be available at this point, and 1/3 of the voltage, as there are 3 resistors, 1/3 of the voltage will be at this point. So the voltage at this point will be 4 volts if we connect 12 volts. Now to understand the circuit, we are going to take a circuit. So this is the circuit. This is the 555 circuit. Here 2 resistors are connected from VCC and a capacitor is connected. This capacitor is point is connected to the 6th pin and the pin number 2. Here the 6th pin, this is 1, 2, 3, 4, 5, 6, 7 and 8. 6th pin is threshold pin. That means this is the 6th pin. So the capacitor one point is connected to this and the other point of this capacitor is connected to pin number 2. That means the trigger pin. This is pin number 2. Here we can see that the pin number 2 is the trigger pin. So how this circuit works? When at the initial the capacitor has no charge, 0 charge, so the voltage at this point will be 0 volt, and this point also will be at 0 volt. Both the voltage will be 0 volt. So this point and this point voltage will be at 0 volt. When this point is at 0 volt, as the reference voltage is 4 volt and this point is at 0 volt, the output will be 1, and this point is also at 0 volt, and the minus point is now higher. So the output will be 0. So this output will be 0 and this output will be 1. This is connected to the reset pin 0 and this output is connected to set pin 1. So the output will be, when reset pin is 0 and set pin is 1, when reset pin is 0 and set pin is 1, the output will be 1 0. That means the output will be 1 here and 0 here. When the this output is connected to, as we can see here that this output is connected to a transistor, a NPN transistor. When this output becomes 1, when this output becomes 1, the transistor base is get a positive voltage and the current will flow through this. The transistor is on and the current is began to flow through this circuit and the LED will glow. So at the initial time the transistor output is at high. As time progresses, the voltage is increasing, and when the voltage is more than 4 volts, when the voltage becomes more than 4 volts, this voltage is now more than 4 volts and this point is also more than 4 volt. When this point is more than 4 volt, this point is 4 volt, so when this point is more than 4 volt, when the negative side is more, the output will be 0. When we check here, this point is at 8 volt and this point is still less than 8 volt, that is 4 volt. So the output will be again 0 here, 0 and 0, both will be 0. When both will be 0, the result is that it will continue in the previous stage. The transistor will be continue in the previous stage. Previous state means it is still continue to conduct. Still continue to conduct. And the LED will glow. Now the capacitor voltage is goes on increasing, and when it crosses more than 8 volt, so now these 2 points voltage is more than 8 volt. When this voltage is more than 8 volt, the negative pin is more than 8 volt, this is again 0. And when this point become more than 8 volt, now it is more than this voltage. When this is more than 8 volt, this will become 1. When the reset pin is 1 and the set pin is 0, when the reset pin is 1 and the set pin is 0, the result is thus it will reset the output. It will reset means it will change the output stage. That means now the output will become 0 here and this will become 1. When the output will become 0, when the output will become at 0, this transistor will be turned off. That means now the output becomes 0, this transistor will be turned off. Now when it becomes 0, it becomes 1. When it becomes 1, this transistor, inside it there is a transistor. This transistor is outside. We are creating a circuit. This is integrated inside the IC. This transistor become on and the transistor act as a short circuit, and this pin, this 7th pin, discharge pin, this pin is connected to this side of this circuit. So now this point will be at ground. When this point will be at ground, the capacitor began to discharge. When this capacitor began to discharge. When the capacitor began to discharge, and again the voltage in the capacitor falls below 8 volts. Again, when the voltage falls below 8 volt, this point again becomes 0. This point again becomes 0, and this point is now more than 4 volt but less than 8 volt. So more than this point is still more than 4 volts. So the output will be 0. So when both will be 0, the output will be in the previous stage. Output will be in the previous stage means it is continuing. This is 0 and this is 1. That means the transistor is off still. Still the transistor is off. Still the transistor is off. When again the capacitor voltage discharges and falls below 1/3 of the voltage. 1/3 of the voltage means when the voltage of the capacitor falls below 4 volts. Now the voltage of this side is less than 4 volt and this side is also less than 4 volts. When both the side is less than 4 volt, this point is less than 4 volt means the output will be 0. And when this falls below 4 volt, this will become 1. Now reset pin is 0 and set pin is 1. When reset pin is 0 and set pin is 1, the transistor output will be again on. Now the transistor become again on. So it is again on. So like that, by charging and discharging, we can able to make a continuous on off of this switch, and thereby we can control the output. This is how a circuit is working. This circuit also contain, as we said, that we can see here this is the ground pin, and the second pin, trigger pin, this is the second pin, trigger pin, and the third pin is the output pin. We can see that this is the output pin, third pin. Fourth pin is the reset pin. There is also a pin, reset pin. This is directly connected. If we apply a low voltage, this will be automatically get resetted. In order to avoid that become automatically low, we are connecting, it is directly to the reset pin is directly connected to the VCC voltage. Now the fifth pin is control voltage. This control voltage is actually connected to this side. This is the control pin. Voltage, this control pin is used to change the voltage. As we said that this, when we apply 12 volt, the reference voltage become 8 volt, this become 4 volt. In order to change that, a pin is connected to this point, and by applying a corresponding voltage, we can change the reference voltage. That is why the control pin is put there. The other pin is threshold pin. This is the threshold pin. This is going to the positive side of the comparator. Next one is the discharge pin. The discharge pin is this pin. This is connected to the transistor collector of the transistor. When this goes high, if this goes high, this transistor will be on, and this point become ground. When this point become ground, the capacitor is discharged. This is the discharge pin, and this is the VCC voltage. So this is the internal circuit diagram of a 555 IC, and this is how it is working. We can make many circuits using this 555 IC, like voltage regulators, constant current control circuits. This we can have many use with 555 IC.